Okay, this is section 8.7. We're dealing with polar coordinates, polar equations, and polar graphs. This is part 1. The goals of this section are to become familiar with polar coordinates, to be able to convert from rectangular to polar and polar to rectangular, to be able to graph polar equations, and to be able to classify polar equations. All right, some preliminaries going into this section. Definitely we're going to be using trig, any trig that we've learned so far. And if you watched the video on 8.5, that was on polar representation of complex numbers, that's going to be definitely helpful because there's a lot of overlap between this idea of polar coordinates and that and 8.5. Okay, the polar coordinate system. So the polar coordinate system serves the same purpose as the rectangular system in that it helps describe a point on the plane. The polar coordinate system relies on a point called the pole and a ray called the polar axis. So here's kind of what the picture looks like. This is in the rectangular plane. This is in our good old-fashioned Cartesian plane. We have the pole right at the origin. The polar axis is just the positive x-axis. And if we want to describe a point on the plane, well, we have a couple of ways of doing so. So here I have a point on the plane. It's this little point right here. Its rectangular coordinates, what we're used to is just x, y. That's its rectangular coordinates. But another way to describe this point is by giving me a radius. This radius is how far away I am from the pole, and an angle theta. The angle is the same thing as how we've been measuring angles. If the angle is counterclockwise, it's a positive angle. If it's clockwise, it's a negative angle. And so then this point right here has both rectangular coordinates, x, y, and polar coordinates, r, theta. Okay, so how do we go back and forth between these rectangular and polar coordinates? We have, if you watch the video on 8.5, well, we've kind of already done this translating. So if you look at this angle theta, I could say cosine of theta is going to be my adjacent x over r. So cosine of theta equals x over r. And then if I try to solve for x, I end up with this little equation, x equals r cosine theta. Similarly, I end up with this y equals r sine theta. I also know that r squared is equal to x squared plus y squared. And I know that tangent of theta is supposed to be y over x. These 4 little equations right here are kind of what help us translate back and forth between polar and rectangular and vice versa. So keep them in mind. Okay. Keep in mind that this little picture here is taking place in the rectangular plane. Let's look at the polar plane. So in the polar plane, you have pretty much the Cartesian plane sort of in there. You can see the x-axis and you can sort of see a y-axis. You also have all of these concentric little circles here. They are, the circles, what they're kind of telling you is a unit of radius. So for instance, from the pole to the first concentric circle, that's radius 1. From the pole to the second concentric circle, that's radius 2, radius 3, radius length 4, radius 5, 6, 7, 8. So this is measuring the length of your radius, the circles. And well, then you're measuring angles as well. Yeah. And notice here I have a point on the polar plane. It's the point r, theta. I guess in this case, the r, the radius, since it happens to lie right on this line, so that's a radius of what? 1, 2, 3, 4, 5, 6, 7. So this is 7. So right here my radius is 7, and then some positive angle theta. This angle theta happens to be between 45 and 60 degrees. Yeah. Notice that I also have associated with this point r, theta, I have sort of the diagonally opposite point, negative r, theta. How does negative r comma theta work? Well, imagine first going negative r, so negative, well, in this case we said r was 7. 1, 2, 3, 4, 5, 6, 7, and then we went some angle theta. Now let me go negative 7. 1, 2, 3, 4, 5, 6, 7. I think I drew this incorrectly. Well, you get the idea. Let me fix this. Let me fix this. Just to make it correct here. It's supposed to be all the way to there. There we go. So now they correspond. So okay, so negative 7, and then I went an angle of theta. Since it's a positive angle, then I'm going counterclockwise. So here, keep in mind, I guess in the previous sections, r was always positive. Now r can be negative. That's the ugliest r I think I've ever written. So let's make a better effort there. R could be negative. All right, so again, in order to plot a polar point, you first go the length of the radius on the polar axis, and then you go whichever angle is being told. If it's a positive angle, you go counterclockwise. If it's a negative angle, you go clockwise. Yeah? Okay, so let's move on. So let's plot the following points on the polar plane. So we were given this points right here. There's 4 points, and we want to plot them in the polar plane. All right, I've sort of color-coded them here a little bit so that we can tell them apart. Let me begin with this A. So 6 and 45 degrees. Yeah, I want to plot this in the polar plane. So the first thing I'm going to do is I'm going to start at the pole, at the origin. I'm going to go first on my polar axis, which is just the positive x-axis. I'm going to go 6 units on the polar axis. So 1, 2, 3, 4, 5, 6. And then I gotta rotate 45 degrees in the positive direction, counterclockwise. So 45 degrees. That puts me right there. All right, so that's my point A. Okay, so pause the video, try to plot the other 3 polar points in the Cartesian plane and label them. Okay, so let's see. Let me plot point B. So to plot point B, I gotta first go 2 in the polar axis. 1, 2. Now I gotta go negative pi over 6. So that's clockwise. Now I gotta go pi over 6 clockwise. That's gonna put me at 11 pi over 6. So I gotta go from 2 clockwise this way. So I'm going to go ahead and say that this is my point B right here. Yeah? Hopefully we agree. Now let's think about this point C. So let's plot that point C. So negative 5, 2 pi over 3. So let me first go negative 5. So I start at the pole. I go negative 5. So now I'm going to the left. 1, 2, 3, 4, 5. That's negative 5. And I gotta rotate 2 pi over 3. And this is in the positive direction. So counterclockwise. Alright. So 2 pi over 3 counterclockwise. So that means 120 degrees counterclockwise. So from here I gotta go 90 and then another 30. So that puts me right there. I would say that this is my point C right there. Yeah, how did I get here? I went negative 5, 1, 2, 3, 4, 5, and then positive 120 degrees, or 2 pi over 3. All right, so that's 120 degrees right there. That's my point C. All right, the last one, D. Let's plot it. So this one is 3, 3 pi over 4. So I first went 1, 2, 3, and then 3 pi over 4. Where's 3 pi over 4? 3 pi over 4 is in quadrant 2. So right there. So again, I go 1, so I start at the pole, 1, 2, 3, and then I rotate 3 pi over 4. Alright, so that's my point D. Yeah. Now notice that with this point D, there's other things. This point D right here, I could have expressed it using polar coordinates a little bit differently. So I could have also have said -3, 1, 2, 3. So -3, so I first go 3 to the left, and then I go clockwise pi over 4. That would mean that the angle is -pi over 4. So -3, -pi over 4 also gets me to the same point. And there's other ways to express this point D using polar coordinates as well. There's infinitely many. Just think about all the coterminal angles to 3 pi over 4. Yeah. So let's think about that for a second. So rectangular coordinates x, y uniquely represent a point on the plane. Polar coordinates do not represent a point uniquely. Yeah. So what do we mean by that? Well, so let's see, let's get into this next little exercise. We're supposed to find 3 distinct polar coordinates for this polar point, 3, 3 pi over 4. So this point, 3, 3 pi over 4, we plotted it up here. It's this last one, it's D, the one in blue. We said that in order to plot this point, we said we go first 3 on the polar axis, and then we go 3 pi over 4. Okay. We said that an alternative to this, though, is to go first -3, -1, -2, -3, and then clockwise pi over 4, or -pi over 4. So that's another alternative here. So I could say here, an alternative to this guy is -3, -pi over 4. Now we gotta think another two. So I'm supposed to find 3 distinct polar coordinates for this point. Okay, I have found one. I need another 2. Can you think of another 2 polar coordinates that represent the same point? 3, 3 pi over 4. Pause the video, think for a second. Can you find some other 2 distinct ones? Alright, so let's look at the point again. So it's point D. We found so far two ways of expressing this point in polar coordinates. Let's think of a third one, or yeah, a third one. So let's see. What if I go first 3, 1, 2, 3, but instead of going +3 pi over 4 this way, I go negative whatever this angle is. I would say that that would also give me the same points, but I guess now you gotta think, what is this angle? What is this negative angle? Now I'm going clockwise. So what is this angle? Hopefully you agree that it's 5 pi over 4. Yeah? So pi over 4, 2, 3, 4. This would be 5 pi over 4, -5 pi over 4. So I'm going to say that another possibility here is 3, -5 pi over 4. What would be a third possibility here? What about this? What about 3, and then let me just do a positive coterminal angle to 3 pi over 4. Positive coterminal angle. So let me just add 2 pi to 3 pi over 4. So 2 pi would be 8 pi over 4. 8 pi over 4 plus 3 pi over 4 would be 11 pi over 4. And they all represent the same point. They all represent the same point in the polar plane, in plane. Okay, so hopefully you see how it is that polar coordinates are not unique. They are not unique. there's many different distinct polar coordinates that represent the same point. So here I have 4 distinct polar coordinates, and they all just point to the same point on the plane. Whereas rectangular coordinates are more unique. They are unique in the sense they're only one coordinate for a point. Okay, let's think about the next example. So pause the video, try to find 3 distinct polar coordinates that represent the same point. All right, so let's see. Let me think. Well, I guess 4 and 230. I could also do what? 4 and negative 130. Yeah, I'm just using the negative coterminal angle here. So 230 and negative 130, they're coterminals. They're just negatives. I could also do negative 4 and 50. Why is that? Think about it. I mean, if it helps, you should plot this point 4, 230. First plot it. In which quadrant does this lie? So this point right here should lie on quadrant 3. Yeah, so quadrant 3. And I agree that this lies on quadrant 3. This also lies on quadrant 3. And I don't know, let's come up with a third one. This guy. 4, 590. If you think about it, 230 and 590, they're positive coterminal angles. It's this one that's maybe a little bit more interesting here, but if you plot this point in the polar plane, you'll see that they are the same point. And there's infinitely, I mean, these are not only, there's infinitely more representations or polar coordinates for the same point. All right, let's get into the next example then. Let's convert let's convert rectangular coordinates to polar coordinates and give 2 representations of each polar coordinate. So pause the video. At this point, what you're going to need is, let me scroll up here. You're going to be needing these 4 little formulas over here. X equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, tangent theta equals y over x. You're going to be needing those right now to be able to do these next examples. All right, so hopefully you've gotten a chance to try this on your own. Let's see. So I want to express this point negative 4,4 in polar coordinates. Let me just kind of visualize the point first. Think about graphing the point. Think about graphing this point, negative 4,4. In which quadrant does it lie? Negative 4,4, I'm going to say that it lies in quadrant 2. Yeah? I mean, I'm just going to kind of make a little sketch of what's going on here. So just later on we can check if our polar coordinates make sense. So that's my point. Yeah? All right. So now let me begin by finding r. Okay, well, r is going to be negative 4 squared plus 4 squared. And that's the square root of 16 plus 16, which I guess is the square root of 32. Oops, sorry. And right now, I should have been careful. Hang on. Let me reverse my stuff here. Because remember, r could be negative. And I already made r positive, and I need to be careful with that. So to find r, actually I should say r squared is equal to negative 4 squared plus 4 squared. That's how I should start this, because r can possibly be negative. Alright, so then that says that r squared is equal to 16 plus 16, or that r squared is equal to 32. And so then r is equal to plus or minus square root of 32, which I guess it's plus or minus 4 root 2. Okay. So I have found r. It could be positive 4 root 2 or negative 4 root 2. I guess it doesn't matter. We just need to give the correct point. Now let me find theta. So I'm going to say that tangent theta is supposed to be equal to my y over my x. Okay, well then that says that theta is supposed to be equal to tangent inverse of -1. And remember right now that the range of tangent inverse is -pi/2 to pi/2. Just a little reminder. And so then if you were to punch this into your calculator, or if you look at the unit circle to figure out what the answer here is, your answer is going to come up with something in quadrant 4. In quadrant 4, because that's where tangent is negative. So the result to this is something in quadrant 4. If you were to punch this into your calculator would say -pi/4 or -45 degrees, which I guess is coterminal to 7 pi/4. But this is in quadrant 4. This is in quadrant 4. But remember, our point is in quadrant 2. So what gives here? How do we reconcile that? So if you think about it, right now, the tangent here is telling you that your angle is over here in quadrant 4. This right here is -pi/4. That's what our computations to find theta have told us just now. Well, that's not what we want. What we want is the angle, I guess, diagonally opposite here. So what would this angle be? Yeah, so I hope that you agree that that's actually 3 pi/4. Or 135 degrees. Yeah, so be careful with that. Sometimes in the process of trying to find the angle, your calculator, your computations might give you something that makes no sense. I mean, here my computations to find the angle gave me some angle that ends up in quadrant 4. Well, my original point is in quadrant 2. So I gotta sort of fill in the blanks here on my own. I cannot just expect this kind of procedure to give me the correct answer. I have to be careful and think about it a little bit on my own. So the angle that I'm interested in is 135 degrees or 3 pi/4, and I guess any coterminal angle to that. Alright, so I think I'm finally ready for the polar coordinates. So I'm going to say polar over here. Well, one possible polar coordinate would be this. 4 root 2, 135 degrees. That's one possible polar coordinate. What's another possible polar coordinate? Another, because we need two polar coordinates. I don't know, another possible polar coordinate would be this. -4 root 2. So now imagine that I go -4 root 2, so now I'm going first to the left. That means my angle should be now negative 45 degrees. So those are two possibilities. You might have been able to come up with different ones, but those are some of the two possible representations of this point in polar form. So try the next one on your own. Give yourself the opportunity to try the next one. Pause the video and try it. All right, so let's see. I am going to begin by also just first kind of analyzing the point to begin with. So 0, -3. 0, comma negative 3. That's right there. That's 0, comma negative 3. It's on the negative y-axis. I'm going to put it there for reference just so that my work in finding its polar form becomes a little bit more intuitive. Okay, let me find the radius. So r squared is going to be 0 squared plus negative 3 squared. Well, that says that r squared is equal to 9 and r is equal to plus or minus 3. So I have found the radius. It's 3 or negative 3. Now let me find theta. Tangent theta is going to be negative 3 divided by 0. Ooh, that's weird. That is kind of strange. Sorry. I forgot an equal sign. Tangent of theta equals negative 3 divided by 0. Alright, so this is undefined here. This is undefined. So how am I going to manage this? Well, think about the original rectangular point. In what would be the angle that's made? Imagine that that a ray starts on the positive x-axis and it rotates counterclockwise all the way to the point 0, comma negative 3. What angle is that? I hope that you agree that that angle is just 270. Yeah. So there was actually maybe not that much reason to do any trigonometry here, but I mean, if you ever encounter this tangent of theta equals something undefined, well, that's probably because you're dealing with an angle on the y-axis. Okay, so then I think I'm ready to express this in polar form. One possible representation would be 3, 270. What would be another representation? What about this one? Negative 3, negative 90. So we said 3 and then 270, and I could go 3, negative 3, and actually positive 90. Over here, in this previous example, we said negative 4 root 2, negative 45. That's clockwise. In this case, it's counter. No, this is okay. This is good. All right, so these are two polar representations of this point, 0, negative 3. All right, let's get into the last little topics in this first part. Let's convert these polar points to rectangular points. This is a little bit easier. The difficulty in the previous example was that you can, there's different representations for polar, but for rectangular there's only one representation. So pause the video, see if you can tackle these things. Convert these polar points to rectangular points. Okay, so let's see. Let me begin by doing the first one. So what I'm going to say is that x is equal to r cosine theta and y is equal to r sine theta. Okay, well then my x is going to be negative 2 cosine of pi and my y is going to be negative 2 sine pi. Alright, what's cosine pi? Cosine pi is negative 1. So I'm going to have negative 2 times negative 1. So that's going to be 2. And my y-coordinate is going to be negative 2 times sine of pi. Sine of pi is 0. So 0. Alright, so that's my rectangular coordinate. 2, 0. And it would help if you actually plot this point in the polar plane to see that they're actually the same point. This is rectangular. All right, let me think about the next example. So similar situation, x is equal to 5 cosine of negative 120 and y is equal to 5 sine negative 120. All right, so what is cosine of negative 120? What is sine of negative 120? So cosine negative 120, that's quadrant 3. So this is going to be negative. And negative 120, this is going to be negative. Let me look at my unit circle here. Cosine negative 120. It's negative 0.5. So negative 5. Or rather, let me write it like this. I'll say this. 5 times negative 1/2. And my y is going to be, so 5 times sine negative 120, and that's negative root 3 over 2. Okay, so my x coordinate is negative 5/2, and my y coordinate is negative 5 root 3 over 2. So those are my rectangular coordinates, negative 5 over 2, comma, negative 5 root 3 over 2. The last one, let's see. The last one, so x is going to be negative 3 cosine 5 pi over 6. And y is equal to negative 3 sine of 5 pi over 6. So 5 pi over 6, what is that? That's 150 degrees, yeah? 5 pi over 6 is 150 degrees. So cosine 150 is negative root 3 over 2. And sine of 150 is 1/2. And so then my coordinates should be 3 root 3 over 2, comma, negative 3/2. Okay, so that's it for this first part. Hopefully this made some sense, and I'll see you for part 2. Okay, thank you.